So it says find the maximum and minimum values of x squared e to the negative 2x. Okay, x squared e to the negative 2x over 0, 5. So this is number 23. F of x equals x squared e to the negative 2x on 0 to 5. I'm going to find the maximum and minimum values here. Okay. So first thing I need to do is take the derivative and set it equal to 0 so I can get my critical points. Let's do that. Okay, so f prime of x, this is going to be a product rule. So it's going to be 2x times e to the negative 2x plus derivative of the first times the second plus the first times the derivative of the second. Derivative of the second is going to be e to the negative 2x. A chain rule is going to say that that's times negative 2. Okay. So this equals 2x e to the negative 2x plus, or I should say minus, 2x squared e to the negative 2x. Oh, that's interesting. And I'm going to set this equal to 0 so I can get my critical values. Okay, nice. So now what I'm going to do is I'm going to factor out what they have in common. Well, they have a 2 and they have an x and an e to the negative 2x in common. So that leaves me with 1 minus x is equal to 0. Now I'm going to see, okay, well, what's going to get me 0 here? Okay, what are my possible zeros? Well, I could let 2x be 0 and then everything goes to 0. So 2x equals 0 means x could be 0. Okay. I could let e to the negative 2x go to 0. However, this is just 1 over e to the 2x, and that will never go to 0. There's no number that I could plug in there that's ever going to make that go to 0. So that will never go to 0. So I can kind of check that one off. That has nothing that will go to 0. And then 1 minus x equals 0. Well, I could toss the x to the other side, and so we get x equals 1. So we have 2 critical values and endpoints here. Well, one of our critical values is an endpoint, so that's convenient. But I actually have to end up testing 3 values. I have to test f of 0, I have to test f of 1, and I have to test f of 5. Okay, I've got to test my 2 endpoints plus my 2 critical values. Okay, so what's f of 0? F of 0 is going to equal 0 squared e to the negative 2 times 0. Well, that's just 0. Okay, so that's good. Okay, what about f of 1? Well, this is going to be 1 squared e to the negative 2 times 1, which is just e to the negative 2, which is 1 over e squared, which is going to be approximately some value. So 1 divided by e squared. To do square root of e? No, I don't want, no, it's squared. Is equal to about 0.1, whoops, sorry. This is where's my starter? 0.135, I'll say, 0.135. It's about 0.135. Okay, and then what's f of 5 going to look like? F of 5. Well, this is going to be 5 squared times e to the negative 2 times 5. Okay, so what is this? This is going to be 25 times e to the negative 10. So that's 25 over e to the 10. So I got to plug that in my calculator. 25 divided by e to the 10. Okay, and that's about 5. Is that right? Well, it can be right. Let's clear that. Oh, that was a really small number. That's why it was doing scientific notation. 25 divided by e to the 10th power divided by e raised to the 10th power. Yeah, this said, okay, here we go. That's better. it's 0.0011, okay, or basically 0.001, okay. So now what's the largest value here? Well, the maximum occurs, the max is at x equals 1 of 0.135, that's the maximum value. And so it occurs when x is equal to 1. What's the minimum value? Well, the minimum value is at x equals 0, and that's of 0. Okay, we have a minimum of 0 at x equals 0. Okay, you could think of this as the 0.135, that's my max value, or 0, 0, that's my min. Okay, that would be my minimum point. Okay, and if you wanted to, you could even go the extra mile here, and you could graph this thing and see, you know, what's the maximum and what's the minimum. We could say, oh, okay, we could go to Desmos, and we could graph this guy and we say, okay, well, what is it? It's x squared. Okay, so x squared, whoops, x squared. Okay, and then it's e to the negative 2x, I believe. E to the negative 2x. Okay, and then we're looking at just from 0 to 5, right? From 0 to 5 is where we want to zoom in on. So from 0 to 5 here, look at that. What's the minimum value? Okay, let's see if I can scrunch this a little. No, it's not going to let me do it. The y-axis, I want to go from 0 to 1. Okay, maybe negative 1 to 1. Okay, and the x-axis, I want to go from 0 to 5. There we go. That's better. Nice. Okay, and so what is our minimum value? Well, our minimum value there is 0, 0. What's our maximum? Oh, look at that. Our maximum was at 1, 0.135. Well, that's kind of cool. Okay, and then at 5 over here, what's it at? It's about 0.0011, right? 0.0011 there. Very cool. So the math, the calculus work matches up with the graph. Awesome. Okay. Okay, Gabriel said he wants to go over 21 next, so let's do that. Okay, 21. Oops. Back here. What was 21? 21, business annuity. Bob deposits $40 per month into an account for spring vacation. The account has an annual interest rate of 3.5% compounded monthly. Find the future value of Bob's account after 1 year, 12 months. What is the rate of change in this value after 1 year? Okay, so $40 per month at 3.5 months for a year. Okay, so write that down. $40 per month for 3.5% interest for 12 months, okay, or 1 year. Okay, so we want to know how much is in the account, right? What's the future value of Bob's account after 1 year? Okay, so we want the future value. Okay, the future value is equal to the deposits times, what was the formula here? The formula, did I share with you guys the formula? Maybe not, maybe not. Okay, I'm gonna put the formula, I'm gonna put the formulas in the chat box real quick, okay? Put the formulas in the chat box. Let me stop my share for a second. I'm gonna give you the formulas sheet here. Okay, so where's the chat box? There it is. Here's my files. I'm gonna go to my files and I'm gonna give you this. Okay, so let's do the formulas. Dropbox. Dropbox. I want my this. I want this. I want this. Nope, I don't want that. Okay, I gotta go steal it real quick. Sorry about this. My bad. I do want you to have this sheet for reference for the exam. Okay. Okay. So let me share my screen again. Sharing is caring. Okay. Here we go. I don't know why I had to have this on this computer, but okay. I'm gonna get it on there now. Okay. Okay, so again, this shows you, this is kind of a finance flow chart. This shows you, okay, with one deposit, one-time interest, this gives you the simple interest formulas. Okay, interest over time, interest earned and the total amount, that's simple interest. Okay, compounded interest, this gives you the compounded interest formula. Okay, compounded interest formula. This gives you the annuity. Okay, this is a many deposits annuity, not and then the amount for each deposit. This is many withdrawals. It's like a loan. Okay, as well. This is total amount. Okay, and then many payments is a loan. It's the same, basically the same thing. Okay, many withdrawals or many payments is the exact same formulas. Let me upload this now into the chat box so you have this spreadsheet or flow chart, sorry, for the exam with you. Okay, so it's good. Come on, stop it. Be nice to me. Oh, there we go. Stop share. Okay, so okay, so there's the flow chart for the finance flow chart. Okay, so that's a good one for you guys to have. Okay. Okay. I'll post that on Canvas as well. Okay. Is there any others that would be good? I think there's another one here that would be good for you to have for the exam too. Let me go here. I mean, you have your notes in front of you, but it just kind of cleans things up a little bit. So let's go here. Let's go here. Cerritos College, Math 116, reference. Ooh, I like this one. Yeah, that's a good one too. I think that's the formulas for everything in the class. That's the formula sheet for everything in the class. Okay, from here on out. Yeah, there you go. Okay, so all formulas that you're ever going to need in this class, one sheet. I'll post that on Canvas too. Okay. You want derivatives? You want derivatives formulas? I don't know if you need them, but I'll give you one. I'll give you those two. So let me give you that too as well. You can, yeah. I mean they're online, but let me give you that one too real quick. So. We don't have. I don't know. Maybe I have to scan it. I'll scan it and send it tonight, I think. Let me see. Let me see what I got here. I got some good stuff. That's the problem with it. Face-to-face versus online, right? So I've got some formulas here. Like these are all the business calc formulas I'd be. Those are all the formulas. That's good. Okay. Blah, blah. Ah, okay. So on the back side, it has summary of formulas for differentiation. Okay, yeah, I'll scan this tonight. I'll scan this right after class. Because it's just a photocopy out of a book. But I'll scan this. I'll scan this formula sheet for derivatives, all the derivatives. I'll scan that tonight and then I'll send it out. Okay, so okay, I think that's all. Is there a file section on? Yes, there is. There's a, well, there. I'll post it. I'll post these files on Canvas. Okay. I'll probably just put it in an announcement. Okay, so this will be all the list of all of the derivatives you will ever need to use in the class. So I don't know where I got that from. I think I stole it from the Math Center or something. Okay. Or maybe I stole it from the book. I don't know. I think it's in the back of the book actually. But instead of having you guys try to chase that down in the back of the book, I'll scan it and send it tonight. So I think you'll be good with all of that tonight. So those three should help you out immensely. On thank you. I did it myself actually, but I appreciate the comment. Okay, it's growing out. So finally growing out. Okay. I started in March with a shaved head. I was like, basically, screw it. I'm done. Shaved my head 6 months ago. That's it. We're done. It's the COVID haircut. So anyway. Okay. Let's go back to the problem. Okay, where we need these formulas. Okay, so what's the deposit formula? Hold that over here. Okay, the value of annuity. Okay, so exactly. It's the COVID cut. So exactly. Okay. Yeah. Okay, so A of t is equal to P or D. And did we use D or P? I think we used D. I don't know. D times, is it D or P that we use? I don't remember. Let's just use P. Okay, that's the present value times 1 plus R over N to the NT minus 1 all over R over N. Okay, so he's going to deposit $40 a month. Okay, 1 plus at 3.5% interest, I think it was, said. Is that right? 3.5% interest. So 0.035. And he's going to do that over a 12-month period. Okay, this is going to compound monthly. Okay, so that's times 12 for 1 year minus 1. Okay, all over 0.035 over 12. So again, the hardest part of this problem is plugging into the calculator correctly. So this is A of 1, basically, after 1 year. Okay, so does this clean up at all? I don't think so. This is 40 times 1 plus 0.035 to the negative 12 to the 12 minus 1 all over 0.035 over 12. Yeah, it doesn't really clean up much. Okay, so clear. Okay, so I'm going to go 40 times first parenthesis, second parenthesis, 1 plus 0.035 divided by 12, close parenthesis, raised to the 12th power, okay, raised to the 12th power, minus 1, close parenthesis, okay, divided by open parenthesis, 0.035, because remember, there's implied parentheses here. 0.035 divided by 12 equals, and I'm getting 487.78. $487.78. So that's how much he can spend on his vacation, little vacay, after a year. Okay. Okay, so now the second part of this is to get the derivative. Ooh, that's fun. Not really. Okay, so A of t, remember, what's the only variable that we're, oh, okay. A of t, what, do you still want me to do the rest of it, Gabriel? I mean, the derivative is the hard part, so maybe we'll just continue, because I'm sure that a lot of people will want to see that anyway. Okay. Okay, so A of t was equal to 40 times 1 plus 0.035 over 12 to the 12t minus 1 all over 0.035 over 12. Okay, so yeah, I'm going to clean this up a little bit first before we take the derivative. Okay, I'm going to go, I'm going to multiply by the reciprocal here. Like, I'm going to take this division by a fraction is the same as multiplying by a reciprocal. Does that make sense? If I divide by a fraction, you just flip that fraction over and you multiply. Okay, it's dividing fractions can be fun. Can be fun when you flip and multiply the lower one. Ha! That's great. It rhymes too. It's awesome. Okay, dividing fractions can be fun when you flip and multiply the lower one. Sweet. That's nice. Okay, I didn't come up with that. I stole that from an elementary school teacher. I actually stole it from her daughter. So there you go. Dividing fractions can be fun when you flip and multiply the lower one. So let's flip and multiply the lower one. Okay, so 40 times 12 over 0.035. Okay, times 1 plus 0.035 over 12 to the 12t minus 1. Okay. Does this clean up at all? Does this, let me just see if this cleans up at all. 40 times 12 is 480 divided by 0.035. Please tell me, no, hell no, that does not clean up at all. That sucks. Okay, so the 480 does. 480 over, okay, 0.035, okay. So I'm going to distribute that, okay, times 1 plus 0.035 over 12, which is not nice, so 12t, minus 480 over 0.035. Okay, so this is a of t. I've just cleaned the algebra up a little bit. Okay, and now I want to take the derivative. Okay, so the derivative of this thing, a prime of t, is equal to okay, so the derivative, well, what's the derivative of this constant over here? Well, that's going to go to 0. He's gone. Okay, and so what's the derivative of this? Well, this is 480 over 0.035. Okay, this is an exponent, right? Exponent. So let's try to remember what we did here for the exponents. Oh, what was the derivative of an exponent? A to the x. Oh yeah, that's right. It was the same thing, natural log a. Okay, so we're going to take the same thing here, 1 plus 0.035 over 12 to the 12.3, and then we're going to hit the natural log. Natural log of what? The base, 1 plus 0.035 over 12. Okay. Okay, and so that's the derivative. So what do we want to do with this? We want to plug in 5, or sorry, plug in 1, I think it was, right? 1 year, after 1 year. Okay, what was the question? What does the question ask again? It says, what is the rate of change in this value, in the value of his account after 1 year? Okay, so how much is it changing after 1 year? Okay. How much is it changing annually after 1 year? Well, see, it should be somewhere around the 480 mark or something like that, but we'll see. Okay, so let's plug in 1 here. A prime of 1. That's 480 over 0.035 times 1 plus 0.035 over 12 to the first power, or sorry, 12th power, times the natural log of 1 plus 0.035 over 12. I don't know why they didn't give us nice numbers here. They could have given us like 6%, which would have been really nice. I wouldn't have to keep writing this 0.035 over 12, but they didn't, but that's okay. We're smart enough to figure it out. And all we have to do now is plug this properly into our calculator and we're done. Okay, so let's do that. Okay, so we've got 480 divided by 0.035, okay, times, okay, parenthesis 1 plus 0.035 divided by 12, close parenthesis, raised to the 12th power, okay, times the natural log, and I got to do this, I have to do it reversed, times, I've got to go the parenthesis first, 1 plus 0.035 divided by 12, close parenthesis, natural log that, and hit equals. And we got 41.36, is that right? I don't know if that's right or not. Did I mess up? Okay, maybe that's the monthly. Let me see. I did mess up. How did I mess up? It should be 496.35. Okay, 496.35. How did we mess up? Let's look at this again. This is 40. I mean, we got that one right, so that one we know is correct. 40 times 12.
Shouldn't it be multiplied by 12 doing the chain rule? By 12t?
Thank you. Yes, thank you, thank you, thank you. I screwed up the chain rule. Yes, so this should be, thank you, yeah, it should be 12t, natural log of this, times 12. Yes, thank you. So times 12. So yeah, all we have to do now is multiply our answer that we got here by 12. Okay, aha, there we go. There's our 496.35. So $496.35 per year. It's a rate of change. So it's got to be per some sort of time interval. So the account is growing at a rate of $496.35 per year after 1 year. Which actually, if you think about it, what we did get was the monthly rate, but that's here nor there. Okay, so account is growing at the rate of per year after 1 year. Okay, so that's good. Okay, thank you for that insight. Okay, other questions that you'd like to go over? Okay, exam is Tuesday, keep that in mind. It's an E, yeah, exactly. So that's the A to the X, that's the A to the X E, this one here. It's a base other than E, there you go. Okay, Darlene says 13, so let's go over 13. Okay, 13 here, let's see what 13 is. Okay, find a function that satisfies this if n is equal to 2 and t equals 0. Okay, if n is equal to 2 and t equals 0. Okay, so this is the exponential growth formula. Okay, so dn dt equals 5n if n equals 2. dn dt equals 5n, okay, if n equals 2 at t equals 0. If n equals 2 at t equals 0. Okay, so we said that this was going to be equal to the rate, r, okay, or k, whichever variable you want to use here. But this is going to be n is equal to n naught e to the kt. I think we used k in the notes. Okay, so that's the differential equation for the exponential growth formula here. And it's saying, look, n is equal to 2 and not when t is equal to 0 and not e to the k. Well, what is k? K is 5 actually, because this is kn. Okay. Okay, k is 5. Okay, because again, dn dt is equal to kn. Okay. Therefore, n is equal to n naught e to the kt. Okay. Okay. And so this is e to the 5t, but what's t? T is 0 here. So this allows me to solve for n naught. So 2 is equal to n naught e to the 5 times 0 is 0. Anything to the 0 power is 1. And so I get n naught equals 2. Okay, well, then what's the equation? The equation is n equals 2e to the 5t. Okay, or I could say this n of t. Okay, so I think that's what they wanted, right? Yeah, so find the function that satisfies this. There you go, there's the function. Function of t, n of t. Okay. Okay, next question. Donovan says 15. Okay, let's do 15. Okay, business. Interest compounded continuously. Ooh, that's a PERT account. An investment is made at 3.512 per year, compounded continuously. What's the doubling time? Ooh, what's the doubling time? Well, that one's easy. Okay, well, what is doubling time? Well, doubling time was equal to the natural log of 2 over r. Oh, okay. So this is the natural log of 2 over 0.03512. Okay, let's just plug that in the calculator. 2 natural log divided by 0.03512. Bam, look at that, 19.73 years, I think it is. So rounded there is 1/10 of a year, 19.7 years. Next. Six. Paul says 6. Okay. 6. 6 was this was e to the x, I believe. Okay. Or e to the x. Natural log x. Okay. So let's see what we get here. Derivative of the first, this is a product rule. Derivative of the first is 4e to the x times natural log x plus the first times the derivative of the second. So the first is 4e to the x times the derivative of the natural log, which is 1 over x. So yeah, so this is 4e to the x times natural log x plus 1 over x. So I'm just going to factor out that 4e to the x. I think that's it. Is that right? I don't know. What's the answer say? 6. Oh, they didn't factor, but that, yep, same thing. Okay, next. 2, the big dose. This is a 7, by the way. This is a 7, I think. That's a 7. Okay, so y equals, okay, and this was a x to the 4th, negative x to the 4th. So for number 3, that's a negative x to the 4th. I'll clean that up a little bit better. Negative x to the 4th. I got to rewrite that. That's just, I got to somehow get rid of that and rewrite it. I got to update that so it doesn't happen again. Okay, so stop, go away. Oh, that's lovely. Okay. So y equals, let's do the derivative of the outside, that's natural log of x to the 6th, times the derivative of the inside, that's 1 over x. So this is going to be 7 over x, natural log of x to the 6th power. Is that number 2? There you go. Okay, you want to do number 3? Let's do number 3. Okay, derivative of e to the negative x to the 4th. That's e to the negative x to the 4th. It's the same thing times the chain rule, which is negative 4x to the third. Okay. The 4 goes down and becomes x to the third. So this is negative 4x to the third times e to the negative x to the fourth. And these should be y primes, by the way. Okay, others?
Excuse me, Professor.
Yeah.
I have a question. So number 7, the exponent in there is x. I have glasses, probably I don't see it right. Is 2 to the, is that little thing an x?
For which number?
Number 7.
Number 7. It's an x.
Yeah, on both of them, 2 and 5, it's an x?
Yes.
Oh my God. So, and number 5 also, e to the x, is that what it is?
Yes, it's an x. Sorry.
Oh God. Okay. So, yeah, I have hard time seeing that.
Try to blow it up, I guess. Oops. A little too big. A little too big. Yeah, it's a little pixelated, so I apologize.
Yes.
That's what you get when you try to scan stuff, I don't know, into a PDF.
Yeah.
I got to get a better printer, I guess. I don't know. Okay, so we wanted number 16. Zoom in a little on this one.
Like on number 20, the formula there, I can barely see it also, this one. 25, letter, I don't know.
Yeah. So at the very beginning of the chat, I don't know if you were in the class yet, but I put in the errata. This is negative 0.25.
Mm-hmm.
Okay. $25, there is no 25. 23, this is an x. Okay, when in doubt, assume x. Okay, this is 2.
On number 3, x to the what is that? Number 3 is y equals e to what?
I have it here. I just did that one.
Oh, you did it. Oh, okay. It's because I'm looking at the paper, my paper on the website, on my computer.
Okay.
Okay. Yeah, it's a good thing it's there, so I can see it as a reference.
Sounds good.
Yeah. Number 6.
Okay, so let's go over 16 now. Okay, the cost of tuna. Cost C of a can of tuna in 2004 was $1.29. The cost in 2010 was $1.87. Find the exponential growth rate to the nearest tenth of a percent. Okay, and then write the equation. Cool, awesome. Oscar should know how to do this one. We went over this one today in tutoring. Okay, let's do this one. Okay. So we have 2004 was 129. Okay, 2004 was 1.29. And 2010 was 187. Okay, 2010 was 1.87. Now, what I'm going to do is I'm going to make 2000 equal to 0. Okay, does that make sense? I'm not going to carry this 2000 throughout the entire. So I'm going to say that at 4, it's 129. And at 10, it's at 187. Okay, does that make sense? Okay, so t equals 0 is 2000. Okay, the year 2000. Okay, when we partied, like it was 1999. Some of you probably aren't even old enough to remember 1999. It's pretty interesting. Well, that's depressing. Anyway, just go listen to the artist formerly named Prince and his song. Okay, and you can relive my glory days. Okay, that's it. Artist formerly known as Dead. Like, oh my gosh. There you go. Eesh. That's what happens. Everybody's like start dying on you. Like, oh my gosh. That's how you know it. You're like, okay. When all your heroes start dying, then you're just like, I'm getting a little old. Like, nature's reminding me of something here. That my life on this planet. Oh my gosh! Do you want to live forever? That was from Highlander, baby. That was exactly. Oh no, that was No One Lives Forever. So I remember. They're all the same. Okay. It was definitely a lie when they told me that I would be forever young in the 1980s. That was a lie. Exactly. To live forever. No one lives forever. It's good. And the guy singing it, Freddie Mercury, didn't live forever. Didn't even make it out of the 80s. So sad. Anyway, I digress. Okay. We know that exponential growth, P, okay, is equal to P e to the RT, right? That's the per account. This is compounded continuously. Okay, I think. Something like that. I don't know. It's exponential growth. We could do the P's and the P naughts if we really wanted to. Okay, but it's exponential growth here. Okay, we're going to let E be our base. Okay, so what are we going to do? Well, we have to solve for two things here. We have to find out first what's R going to be and what's P not going to be. Okay, so this one's kind of tricky in that if I plug in 1.29 and I get P naught E to the to the R times 4, okay, so interesting. I'll get 1.29 equals P naught E to the 4R. Okay, let's divide by E to the 4R. Okay, good. Let me make sure I'm doing this right. Exponential growth rate. Yep. Okay. So exponential growth model. Yep. Okay, and so we're going to say that P naught here is equal to 1.29 E to the negative 4R. Okay, so that's what P naught is equal to. Okay. Now, how's that going to help me? Well, I'm going to set up another equation. Okay. This is my first equation. I'm going to set up another equation based on the other information that I'm given. That's 1.87 is equal to P naught E to the 10R. Where did I come up with that? Well, it's 10 is the time, and it's going to be the rate. So what am I going to do? I'm going to sub this in for P naught. Okay, and I'm going to get 1.87 is equal to 1.29 e to the negative 4r times e to the 10r. Okay, well now I'm going to add the exponents here. Negative 4 and 10 plus 10, negative 4r plus 10r is 6r. Ooh, okay. So this is going to be 1.87 is equal to 1.29 times e to the 6r. So now I'm going to divide by 1.29. Okay, and I get 1.87 over 1.29, okay, is equal to e to the 6r. Now, how do I undo the e? I take the natural log, right? Take the natural log. Okay. So this one's going to be the natural log of 1.87 over 1.29 time is equal to 6r. I'm going to divide by 6. And that's it, that's the rate. So the rate is going to be approximately whatever this thing is. Let's plug that into the calculator. We want the natural log of well, let's do the 1.87 first. 1.87 divided by 1.29, close parentheses, take the natural log of that, and then divide that by 6. And I get 0.061 I said, or 0.06188, 0.06188, okay, or maybe we'll just do the 9 here. Okay, so this is going to be 6.19%, or I could just go 6.2% on this. 6.2%, okay. 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 Okay, so this is people who wanted to make money. That's who. The rich people. Okay. You could blame it on the 1%ers if you want. You can do that. That's okay. Okay. There you go. It's all good. Okay. It's all the people on Wall Street, right? It's all the people on Wall Street that came up with this stuff. It's like, hey, how can I make more money? Show me the money. Show me the money. Show me the money. Channeling my Jerry Maguire. Show me the money. Okay, so that's the rate, right? So how am I going to find out what the formula is? Well, I'm going to plug this R that I just found in here, and I'm going to solve for P naught. Okay, so P naught is equal to 1.29 e to the negative 4 times the rate that this is going to be 0.062. Okay, so I'm going to multiply this. I'm going to take, what's nice is I already have this number in my calculator. So I'm going to take this number and I'll multiply by negative 4. Negative. Okay, hit equals. Then I'm going to do e to that exponent. Okay, so to the exponent. How do we do this? Let's go see. E equals. Did not want to do that. Okay, so that's fine. Let's do 1.29, blah, 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 1.29 times e raised to the parentheses negative 4 times 0.062. Is equal to, what is that, 1.006? That's 1.01, I could say. So P naught is equal to 1.01 maybe? Okay, that's fine. Okay, there's some rounding going on here. So, okay. So what's the formula? The formula is this: P is equal to 1.01 e to the 0.062 t. Oh, okay. Okay, so now they're asking me, we can make this P of t basically. Now they're asking me, okay, we'll find out what is going on. Okay. Find out what's going on in subsequent years, right? So it says, find the cost of a can of tuna in 2012 and 2018. Okay, so 2012. So here all I have to do is plug in 12 for t, when t equals 12, and then when t equals 18. So this is going to be this number here. Okay, 1.01 times e, okay, raised to the 0.062, oh, I forgot the parentheses, my bad. Parentheses, 0.062 times 12 equals, okay, so $2.13. $2.13 in 2012. Okay, what about 2018? Use this as a predictive model. This is now a predictive model. We're predicting the future based on the past. Okay, we're saying that it starts at 1.01 and then it goes up exponentially based on what happened at 2004 and 2010, right? Something like that. That's what it was. Yeah, 2004 and 2010. So now we're predicting what's going to happen in 2012 and 2018. Okay, so plug this back in, clear. Okay, 1.01 times e raised to the 0.062, oops, again, I forgot the parentheses, 2 times 18 equals, whoo, that's a lot for a can of tuna. Jeez. Okay, 3.08, $3.08 in 2018. All those people in their damn nets and killing all the dolphins. Makes my tuna prices go up. Okay, and kill my dolphins. Okay. Stop it. Stop killing the dolphins. Okay. So it reminds me of a line. It's a funny line. You guys might think it's funny, but it was a funny line. Has anybody ever seen the Lethal Weapon? The Lethal Weapon series? Well, there's Lethal Weapon 3. There's a funny line where there's a dog and they're trying to get past the dog. And the Braveheart guy, what's the Braveheart guy? Mel Gibson. Mel Gibson turns to Danny Glover. And Mel's like, why don't you just shoot the dog? Because they're cops, right? They're just like trying to get past this dog. He's like, why don't you just shoot the dog? He's like, he turns to Danny Glover, or Danny Glover turns to Mel Gibson and he says, we don't shoot dogs, we shoot people. I thought that was funny. So, anyway. So, same thing. Stop killing my dolphins. Okay. Anyway, I digress. Okay, next one. Miriam wanted 22? 22. Let's do 22 here. Okay, 22. Okay, differentiate this guy. Okay, so different time, I guess. Okay, so we want to do product rules here, 2 product rules and a chain rule. Okay, so let's do that. Let's take y prime is equal to, product rule of the first one here is going to be 4 times natural log x squared, okay, plus 4x times, the derivative of natural log x squared, that's going to be 2 natural log x, okay, to the first power times the derivative of natural log of x, so that's just 1 over x. Okay. Okay, so let's simplify this before we go on to the next one. So this is going to be 4 times the natural log x squared plus this x and this x are going to cancel out. So this becomes 8 times the natural log of x. Okay, and then minus, okay, minus 8 times the natural log x. That's nice because we're taking the product rule of the next one, but look at that. Okay, minus 8x times the natural log of x. Well, what's the derivative of natural log of x? Is 1 over x. So those x's cancel out. Okay, plus 8x. Well, what's the derivative of 8x? It's just 8. So this is a minus 8. Let me clean this up a little. This is 4 times natural log x squared plus 8 times natural log of x minus 8 times natural log of x. Cancels. Minus 8 plus 8. Well, that cancels too. So that's it. The first term is the only thing that survives. And I get y prime. There we go. Anyway. Okay, what was the next one that we had here? If it's yellow, then it would be more. Oh, yes. Get it. Tough crowd. Okay, what next one that you want? Let me know. Are we good? We're good, and we're good.
Oh, Professor, someone said 17.
They did. Okay, so let me look at the chat. 17, there we go. Okay, thank you. Perfect. Okay, let's go over 17. Oh, nice. Look at this one. Okay, so what's the function that satisfies this? Okay, so this is going to be, I guess, n of t is equal to n naught times e to the negative 0.18 t. Okay, that's that one. When t is 0, there are 200,000 bacteria. So what's n naught? Well, n naught is my initial value. That's my n naught, or n sub 0 is my value at time 0. So this just becomes n of t is equal to 200,000 times e to the negative 0.18 t. Boom, that's it. Okay, how many bacteria will remain after 10 hours? Okay, how many bacteria will remain after 10 hours? We'll just plug in 10 here for t. We get n of 10 is equal to, plug in for 10, that's going to be, I don't have a lot of room here. If I go to my other screen. Okay, so we have n of 10 is going to be equal to 200,000 times e to the negative 0.18 times 10. Okay. Okay, and so we're going to plug this into a calculator. This is going to be 200,000 e to the negative 1.8. Okay. Let's see what we get here. 200,000 times e to the negative 1.8. 1.8 negative. Let's try that again. Times e raised to the negative 1.8 power. Okay, is 33,059.78. 33,059.78. I think this was bacteria, right? Or death by bacteria or something. I forget what the question is. Remember, bacteria, yeah, it's decreasing at a rate of 18% per hour. Okay, so the T is in hours. Okay, so after 10 hours, yep. So just plug in that. So how many bacteria are there after 10 hours? Well, there's 33,000. Okay, we can round to the nearest bacteria. So this is going to be 33,060 bacteria. Okay, so 33,060. Right? Yeah, bacteria. Okay, after how long do half of the original bacteria remain? Well, this is the half-life, remember? So what's the half-life formula?
ln2.
An ln of 0.5, right, over r. ln 0.5 over r this time. Okay, so what was the rate? The rate was 18%. Okay, so this is going to be ln 0.5 over, and it's going to be a negative 0.12. I'm going to have to be the negative 0.18. Okay, make it a negative rate because it's decreasing. Okay, if you want to do negative r, you can. It doesn't matter. Okay, just have to know that the bottom is negative. Okay, so ln 0.5. Okay. Okay, ln 0.5. ln. Okay, divided by 0.18. Okay, is 3.85. Okay, so 3.85 hours. So how long until half of them are gone? 3.85 hours. Until we go from what? We went from 200,000 to 100,000, right? In 3.85 hours. There you go. And then this guy here was just the model. Whoa, what the heck is that? Are you guys seeing this? Oh, what happened there? They moved everything that I drew. Okay, so this is going to equal 200,000 e to the negative 0.18 t. There you go. Okay, what else we got here? 20. Donovan says 20. Okay. 20. Okay, so yeah, let's do this one. Okay, this is that logistic growth model, right? Logistic growth. Remember Thanos? You talked about the Thanos man. Okay. So we start at 1 and we go up here. Okay, 2. Okay. What the heck? Why does it keep flashing on me? Okay. Okay, and so Okay, and the boundary here is 100. Okay, I'm going to stop sharing my screen for a second so that it stops flashing. Okay. So let's see what we got here. Okay, what percentage of people bought the product before seeing the ad, or T equals 0? Okay, what percent of people bought the product? Okay, well, when T is 0, we just plug in P of 0. Okay, so this is the percentage of people who will buy after the ad has run. Okay, so P naught, okay, is equal to, and again, 100% would be everybody. Okay, but can't have over 100%, so that's why there's that boundary there at 100%. So P naught is going to equal 100 over 1 plus 20 e to the negative 0.25 times 0. Okay, well, e to the 0 power, that's just 1. This whole thing goes to 1. Okay, e to any base to a 0 power is 1. And so this just becomes 21. So this is 100 over 21. So I don't know what is the percentage for 100 over 21. Is about 4%, 4.7, 4.8%, I'll say. Okay, so 4.8% of the people bought the product without even seeing the ad. Okay. What percentage of people bought the product after the ad has run 1 time, 5 times, 20 times? So I guess T is the number of ads that have run. Okay. So we just have to plug in to our function here, 1, 5, and 20. So I'm not going to run all of those. Okay, maybe I'll run one of them. Okay, but this is going to be 100 divided by parentheses 1 plus 20 times e to the negative 0.25 power, e to the negative 0.25 power. Did I miss the e somehow? Where did the e go? Okay, plus 20 times e raised to, there we go, the negative 0.25 power. Okay, let's do that one. Oops. Negative 0.25, 0.25 negative power. Okay. Equals. I think that's it. Let's go back here. Okay, and so yeah, just I think that's it. Is there another equals here? No. Okay, equals. We're hitting equals, it'll keep screwing my up. But okay, so let's clear that. Let's try it one time. 100 divided by 1 plus 20 times e raised to 0.25 negative power of 0.25. Okay, so yep, that's closed parentheses. Okay, and then equals 6.6%. Okay, 6.03%. So 6.0, I'll just say 6.0%. Okay, for the first one. Okay, and then you can figure out the subsequent ones there. Find the rate of change of P prime of T. Okay, so let's do the rate of change down below here. So P of T is equal to 100 over 1 plus 20 e to the negative 0.25 t. Okay, so let's find the rate of change of this thing. So we could do a quotient rule. I don't really want to. do a quotient rule on this. I'm going to change this. I'm going to go 100 times 1 plus 20 e to the negative 0.25 t to the negative first power. So I just took everything on the bottom and made it a negative exponent. Negative first power. Okay, so that's still p of t. So now what I want to do is do p prime of t. Okay. Okay, so this is 100, okay, times negative 1 plus 20 e to the negative 0.25 t. Jeez, why this thing just keeps freaking out on me. Okay. Maybe I'll go to the other thing in a minute. I'll just solve it there. But to the negative 2 power, right? So this is a chain rule. So this is going to be times the derivative of the inside. Well, that's 0. The 1 is 0. This is 20 e to the negative. This is 20 e to the negative 0.25 t. Okay, times negative 0.25. That's a chain rule. Kind of like a chain rule inside a chain rule. Okay, times negative 0.25. Okay, so I can multiply that negative 0.25 times 100 here and make it a negative. I could combine these three together and the 20 as well. Okay, so 0.25 of 100 is 25. 25 times 20, those two negatives cancel each other out. That's kind of nice. Okay, and 20 times 25 is what, 400? So this is going to be 400. Okay, times 1 plus 20 e to the negative 0.25 t to the negative second power. Okay, which is equal to 400 over, geez, that's annoying. Okay, 1 plus 20 e to the negative 0.25 t. Okay, and all of that is squared on the bottom. You know, I'm getting tired of this flashing stuff. Okay, so now it says part D, sketch the graph of the function. Okay, so we said that at time 0, we got, right, we got, what was it, 4% or something like that? 4.8%. So at time 0, we're at 5%. And then what are we going to do? We're going to go up to, okay, we could plug in for various points on this graph. Okay.
Professor, excuse me. I am following you, but I just don't understand what is it, the numbers that you wrote on, like where the number 50 is, like on top of it.
50?
Yeah, you wrote some numbers between parentheses on top of the number 50 in there.
It's negative 0.25.
Negative 0.25.
Yeah. Sorry.
Okay, thank you.
I had a hard time fitting it in. Doesn't erase well. I says 500, not 400. Oh, maybe that's, maybe I did that wrong. Okay, so what's 20 times 25? Isn't that 400? Oh, 20 times 25 is 500. Oh, okay. That's so much, that's how much what do I know? Thank you. Perfect. Okay, well, obviously I cannot multiply in my head. That's why I use a calculator. So. Okay, and so again, you could plot some points here, but you just know that at the very top, tippy top, right? The very tippy top, we're going to have a boundary. So I don't know where the halfway mark is going to be. Okay. Again, we're going to start. Oh, we could plug in these values that we found up here for part B, right? So at 5, this is 1, 5, and at 20, right? So what were the percentages for that? What did the answer key say? The answer key says 14.9 and 88.1. Okay, so 14.9 and 88.1. 14.9 and 88.1. Okay, that's cool. It's going to give us some nice value of data there. So at 5, we're at 14.1. Okay. And at 20, we're at 14.9. And at 20, we're at 88.1. 88.1. About right there. So what's this doing? Going up like this and tapering off. Mind blown. Okay, so number 10, Donovan says, do number 10 now, sir. Like, okay, let's do number 10. Okay, log base B of 36. Oh, this is a good one. Okay, so log base B of 36 is equal to log base B of 6 times 6, okay, which is equal to log base B of 6 plus log base B of 6. Okay. The other way that you could think about this is this. You could think of this as log base B of 36 is equal to log base B of 6 squared. So then I could bring this 2 in front. And so this becomes 2 log base B of 6. So it's just using those properties of logs. Okay. And so they tell us what is log base B of 6? It's this thing. So this is just going to be 2 times 1.2925, whatever that comes out to be. Okay. 2.385 or something. I don't know. 2.585. I don't know. Yeah. 2.5.
It's 2.585.
Yeah, 85. Well, thank you, Maria. 2.585. Okay, next. Okay, so what's happening? on Tuesday. Tuesday, I will be in the Success Center from 9 in the morning until 4 in the afternoon.